I'm Melinda Duer. I'm Professor of Biological and Biomedical Chemistry here in the Department of Chemistry in Cambridge. My group works on the understanding of the molecular structure of biological tissues, so things like our skin, bones, tendon, to work out how to tackle diseases like hardening of the arteries, ageing, and diseases like cancer. So I grew up in Hertfordshire, Australia, Essex, and eventually settled in Cornwall, where I went to the local comprehensive school, Sir James Smith School in Camelford. And it was there that a chemistry teacher, Mr. Trevithick, persuaded me to apply to Cambridge. I seemed a bit mad. None of my family had ever been to higher education, they'd never had the opportunity. But I applied and I got here. So I absolutely love being a student here. Almost immediately, I guess, I met a group of like-minded people who are still amongst my best friends today. When did I fall in love with science? I think it was when a professor of physical chemistry gave my lab partner and I a high-resolution infrared spectrum of a gaseous emission. Now, when I say a high-resolution infrared spectrum, I mean something that was like 10 metres long. We could only unroll about 2 metres of it at a time. But I just really loved getting into the detail of that spectrum, working out what each of those signals meant, and I think that's when I decided science was the thing for me. As we live longer, our quality of life is in danger of serious deterioration because of the ageing process. But that ageing process is exacerbated by chronic and degenerative diseases like osteoarthritis, osteoporosis, cardiovascular diseases like hardening of the artery, and of course, more seriously, immediately life-threatening diseases like cancer. All of those diseases involve our tissues. Not just the cells in them, but critically the material between the cells, the extracellular matrix, which is actually what makes up the bulk of our tissues and gives them their mechanical properties. So the extracellular matrix is what makes bones strong but flexible, makes arteries compliant, makes skin elastic. But the chemical structure of that tissue, the chemical structure of the extracellular matrix changes with age, and critically it changes in degenerative diseases and is a strong underlying cause in cancer as well. So we want to find ways of combating the most serious parts of the ageing process, and we want to find ways of combating degenerative diseases like osteoporosis, like osteoarthritis. We need first of all to know what those chemical structural changes in our tissues are, and then we need to work out what causes them. So that's what my research group does. We use a whole load of different techniques to work out what the molecular structural changes in our tissues are with disease and with ageing, and then we kind of work backwards to work out how they got there. So what do I love about science? Oh, so many things. Well, I guess one of the things I really love is that it's a global language. There are very few cultural or geographical boundaries in science. And then day to day, what I love that piecing together of complex data. It's like getting little bits of evidence from here and there, going over and over it, and then just suddenly realising what it's all telling you and seeing the bigger picture for the first time. And then you start to realise that you're understanding something that people just haven't understood before. And then you start to think, hey, this could actually help people. What would I tell my undergraduate self? Oh, quite a lot. Well, I guess I've never had a lot of confidence. It took me years to realise that other people don't either. But I think what I'd really like to say to my younger self is, if that's what you want to do, just go and do it. Doesn't matter if you turn out to be good or bad at it, just have a go.